Hello.
Hello.
Yeah. Can you hear me?
Yeah.
Okay. So in today's class, we'll do a slightly different thing. We'll do some practice problems today. We'll continue with the theory in next week's class on number theory.
Okay.
So we have already covered quite a lot. We should be able to handle some problems. So we'll just solve some questions today. Okay.
Okay.
So the first one is this one. The acute angles of a right angled triangle are acute angles of a right angled triangle are A degrees and B degrees. Both A and B are prime numbers. What is the least possible value of B? And here it is given that A is greater than B.
So wouldn't the least value just be the smallest prime number?
You have to find the answer. A
Okay.
is greater than B. A and B are acute angles and of a right angle triangle. And they are all prime numbers, A and B.
Oh, right, right. They're all prime. Okay. So B would be 7 and A is 83?
Hmm. Because you want to make B as small as possible.
Yeah.
If B was 2, 3, or 5, then A would not be prime, right?
Yeah.
The sum of the angles have to be equal to 90.
Right.
Okay, that's pretty simple. This is AMC 10 only. All of these questions that we'll be discussing today are previous contest problems.
Oh,
The
okay.
next one is let P, Q, R be prime numbers such that 2PQR plus P plus Q plus R is equal to 2020. You have to find PQ plus PR plus QR.
Okay.
Second one is doable. You have to think carefully. Tell me if you have any ideas so far.
Uh, so what I did is that because we know that 2 PQR is going to be even, so that
Hmm.
means the sum of P and Q and R, that all has to be even. So then one of them has to be an even number because three odds won't make an even.
Hmm.
So I just said randomly, let's say, I don't know, R is 2.
Hmm.
So then you get that 4PQ plus P plus Q is equal to 2018.
Hmm.
And then I took Q common and I said Q times 4P plus 1 plus P is equal to 2018.
You are on the right track. So far, everything you have done correctly. At this
Mm-hmm.
step, try to do this thing, this factorization of the left-hand side somehow, right?
Factorize.
See,
Yeah.
you have already taken Q common, right?
Yes.
Like you got 4p plus 1, right?
Yeah.
Technically, you have to make sure that it factorizes. So that factorization would help you. No, you don't want anything else. You just want products here, right?
Right, right. Yeah.
So one way to do it is just Q and 4p plus 1, what you got, take a 4 out from it also. So you'll get a p plus 1 by 4, right?
Yeah.
And then you have just a p here. You can add 1 by 4 to both sides, obviously.
Right.
You understand what I'm saying?
Yes.
In order to make it match here, you need to add a 1 by 4.
Yes.
So write it as 4q, p plus 1 by 4
Mm-hmm.
plus p plus 1 by 4 is equal to 2018 plus 1 by 4,
Okay,
right?
yeah. Yeah.
And then you get p plus 1 by 4 into 4q plus 1. So you can take a 4 out from there also. And basic, or you can just write 4q plus 1 into 4p plus 1 by 4, right?
Yeah.
Is equal to 2018 plus 1 by 4. So you will multiply by 4 here, you get 8072 plus 1, right? 8073 is the product of 4p plus 1 and 4q plus 1, right?
Mm-hmm. Yeah.
Do you understand? Till here, everything is right. You have to look at even odd stuff and realize that one of the primes has to be 2.
Yes.
When you get this equation, it's about factorizing. If you don't factorize it, you can't do much after that.
Yeah.
When you take common, this is called Simon's favorite factoring trick, where you add the constant that you need, right?
Oh, right. Yeah.
Like there is a missing constant. If there is an appropriate constant, you can factorize it, right?
Yes.
So that is the trick, that you always add the constant that you require to make the factors match, right?
Yeah.
So now our equation has become 4p plus 1 times 4q plus 1 is equal to 8073. These are
Uh-huh.
prime numbers. The best way to figure it out is to do the prime factorization of the right hand side and then try to see how we can match it and all, right.
Right.
We already know R is 2.
Mm-hmm.
So we just need to figure out what P and Q could be.
Yes.
So do that now.
Okay. The prime factorization is 3 to the power 3 times 13 times 23.
Mhm. Then try to figure out how can we make it a product of two numbers, right? Two
Right.
numbers of the form 4p plus 1, 4q plus, where p is some prime number.
Mm-hmm.
So obviously, both the numbers will be odd, right?
Yeah.
You have to write it as a product of two odd numbers.
Yes.
You can try different combinations like 3 power 1 into 13 and 3 square into 23, right? But this fails because this is 39. 39 is not 4p plus 1, right?
Right.
This fails because of that, because it's not 4p plus 1 or 4q plus 1, right?
Yeah.
3 square into 13 and 3 into 23 will work. 69 is also there and 117 is also there.
Yes.
Do you understand? Both of them are 4q plus 1, 4p plus 1.
Yes.
You can take any other combination. 3 cube into 13 and 23, but 23 will fail, right?
Yeah.
Then you can take 13 on other side, but already you gotten one answer by the way, right?
Right.
So it's unlikely that there will be multiple answers because
Right.
these are like objective type questions and all. So uh,
Yeah.
you will get, once you've gotten one answer, you can just find P and Q from here, right?
Right.
So 4P plus 1, P is 29 and 4Q plus 1, then Q is 17, right? And R is already 2, we know.
Yeah.
This is one of the answers. Maybe if you take some other pairs, you might get other answers also. But we found one answer at least.
Yes.
Do you understand what I'm saying?
Yes, I understand.
Okay. Third, 3 and 4. You have 5, 6 minutes. Try out both of them.
Okay.
Have you got something for third one?
Yeah, for that one I got 60. I mean 6 as the sum.
Right. That is correct. Yeah.
And then I'm doing the fourth one.
Hmm. You have to go step by step here, right? So if 5 factorial is this and 10 factorial is this, think about LCM when I take and GCD when I take.
Mm-hmm.
LCM, you take the higher powers, right, of prime numbers.
Yeah,
And in GCD, you take the lowest common power, right?
right.
So look at all the prime numbers one by one, 2, 3, 5, 7. So if you look at the prime 2, on the
Yeah,
left hand side, LCM of something and something, then lowest common number, at least 3 has to be there, right?
yeah,
Three twos have to be there. Uh,
right.
on the right hand side, it's a GCD of 2 power 8 and n, whatever n is, right?
Yeah,
So it will be less than equal to 8 for sure.
right.
Correct, no?
Yeah,
So it is the power of 2 will be 3 less than equal to x less than equal to 8, right?
right.
Like this, you can make conditions on each prime number's power, right?
Yeah,
So write down those conditions. That will be what will be useful for you.
okay. So like for 3, it would be uh the power has to be between 1 and 4.
1 to 4 for 3.
Yeah, and then for 5, it's just 1 or 2.
For 5, LCM has to be bigger than 1, and this side there is a 5 here also.
Yeah.
5 into 5 squares GCD, right?
Yes.
So less than equal to 3, no then.
Oh, right. Yeah.
Do you understand what I'm saying?
Yes, yes.
1 second.
Because there's another 5 in the front.
Um, Wait, we have to be careful here. Uh, so 5 LCM part is fine. 5. The power has to be bigger than 1, greater than equal to 1. And let's say n was something, 5 power something.
Yeah.
Uh, so let's say n was equal to 5 power a into x, let's say. When you take GCD of 10 factorial and n, what will we get? We get the lower number out of 2 and a, right?
Yes.
Minimum of 2 and a, right?
Right.
That will be the power of 5 there, right?
Yeah.
So you'll do 1 plus that, right?
Right.
So n has to be greater than 1. The power of 5 from the left hand side should be greater than 1, but it should be something like 1 plus minimum of 2 and a, right?
Yes.
But minimum of 2 and a will at least be 2, right?
Correct.
It could be minimum of 2 and a. A can be 1. If a was 1, what will happen? Is it possible for a to be 1? Right. A could be 1 also, no? Oh, wait. If A was 1, then when you do LCM here, you will get 1 only, right? Here.
Oh, right. Yeah.
If A was 1, the LCM would have a power 1. 1 is less than equal to 1 plus 1. It doesn't work, right?
Right.
1 second. See, they will not be equal because 1 will be equal to 2 then. If A is 1.
Yeah.
Do you understand what I'm saying right now?
Yes.
Because left hand side will have power 1 if A is 1, and right hand side will be 5 times GCD. GCD will give us power of 2 and 1, minimum is 1, but 1 plus 1 is 2, right?
Yeah.
So 1 doesn't work, right, for A.
Right.
So A could be 2. If you put A is 2, the right hand side is 3, right?
Yes.
But left hand side is again 2, correct?
Correct.
So A has to be, if you put A is 3, minimum of 2 and 3 is 2 plus 1, 3. Now it is matching, right?
Yes.
Do you understand that for 5 the power has to be 3?
Yes. Yes. I understand.
Because of this multiplication, it is more complicated here. Okay.
Yeah.
So you have to think of, okay, let's assume it is some power into something else, and then think of trying to match the powers on both sides.
Yes.
1 and 2 doesn't work because left hand side is not going to be equal to right hand side at the end when you do everything. But 3 does
Right.
work because when you do LCM of 5 factorial and something 5 cube and all, then the LCM, the coefficient of 5 here would be 3, and the other side would be 1 plus minimum of 2 and 3, which is 1 plus 2, which is 3, right?
Yeah.
If you go for higher powers, what will happen? If A is 4 and all, this side is 4, but this side will be stuck at 3, no? Do you realize?
Oh, right, yeah.
Right hand side will always be 1 plus minimum of 2 and A, right?
Yeah.
So if A is bigger than 3, A is 4 and all, still it is 3, right?
Right.
But the left hand side will keep getting higher because it's LCM.
Right.
So nothing else will work, no? 4 and all, 5 and all will not work.
Yeah.
So power of 5 is already fixed, it is 3, right?
Yes.
Now think of 7.
For 7, there's only one option.
So
Only
if you
one.
think about it, now n can be 7 power b into some x, right?
Yeah.
When you do LCM, there is no 7 here. So LCM will simply b here, the left hand side, right?
Yeah.
And on the right hand side, it is the GCD of 7 power 1 and 7 power b into x, right?
Yeah.
So GCD will be 1 here, right?
Right.
Correct? No, always it will be 1, no?
Yeah.
So B has to be 1 then, right?
Yeah.
So only one option for 7 also, right?
Correct.
Wait, is 0 is possible? Okay, 0 is also possible. We forgot about 0. It could be 7 power 0 also.
Oh.
If there is no 7 anywhere, then LCM here would have power 0 here, right? And
Yeah.
here GCD will have 5 times GCD of 10 factorial and 7, something which doesn't have 7. So it will have lower value. So it will be, it can also be 0, right?
Right.
We can take 0, no? Factors doesn't have to have that prime, right?
Yeah.
So 7 could be 0 or 1, right?
Right.
Do you understand what I'm saying?
Yes.
So now we have figured out all the prime numbers and their relevant powers, right?
Yeah.
Now you have to count how many such integers you can make, right?
Right.
That's not very difficult because integers are going to be made by products of primes, right?
Yeah.
So for 2, how many options are there?
Uh, 5.
5, 3, 4, 5, 6, 7, 8. 6 options, right?
Oh,
3,
yeah,
4,
because we're,
5, 6, 7, 8, right?
yeah.
And for 3, how many options are there? 1, 2,
Uh,
3, 4.
yeah.
For 5, there is only one option. For
Mm-hmm.
7, there are two options, right?
Yes.
So the number of numbers you can make, you can pick any powers of all of this. So 6 options for 2 multiplied by 4 options for 3 and 2 options for 7, right?
Yes.
So that will give you the answer. That will be basically 48 numbers.
Yeah.
You can pick any power, it will give a different number as soon as you pick a different power, right?
Right.
This is like basically multiplication principle from counting, right?
Yes.
Do you understand?
Yep, I understand.
So we are getting 48 numbers which will satisfy this condition. The main thing is to figure out the powers of the primes, right? And the
Right.
range of powers. Once you figure that out, after that, it is just a simple counting problem, right?
Yeah.
Okay. The next problem is this one. Uh, find the number 7 tuples of positive integers A, B, C, D, E, F, G that satisfy the equations ABC is equal to 70, CDE is equal to 71, and EFG is equal to 72. These are positive integers that have been multiplied to create this situation.
Right.
So you have to think of how you would proceed here. One thing to keep in mind is that there are sometimes common integers in equations, right? See, first
Yeah.
equation and second equation has C common, right?
Yes.
We know C divides 70 and C divides 71, right?
Yeah. So then C is just 1.
Right. Because 71 is a prime, C
Yeah.
can be 1 or 71, but 71
Mhm.
will not fit this condition. So C
Right.
is simply 1, right?
Right.
Similarly, you can say E divides 71 and E divides 72 also,
Yes.
right? So
Right.
obviously same logic, E is also 1
Right.
because 71 is a prime, right?
Yes.
So now the equations are much simpler because you have two values are already there, right?
Yes.
AB is 70,
Mm-hmm.
D is 71, right? And
Yes.
FG is 72. So now we know C is 1, E is 1, and D is 71, right?
Yes.
Now you have to figure out this stuff. A, B, F, G.
So that would just be like how many factors?
So now try to figure it out.
Okay. So for 70, there's four factor pairs. 1 and 70, 2, 35, 5 and 14, and then 7 and 10.
But you could reverse it also, right? So there are totally 8
Yeah.
ways.
So then 8. And then for 72, and then for 72, there's 12 factor pairs.
8 into
So
12 ways to do this, right?
yes.
You already know these three, so you don't have to worry about them.
Yes.
So 96 is the answer. So again, the question relies on a simple thing about prime numbers, right?
Right.
If you know this basic thing that only 1 and the prime can divide it, right? Then you will be able to
Yes.
solve the problem.
Right.
This was AIME 2019. So again, not very difficult, it's doable. Okay.
Yes.
Okay, next one is let A1, A2, A3, A4, A5, A1, A2, A3, A4, A5 be positive integers such that A1, A2, A3, A4, A5 are in geometric sequence. You know what a geometric sequence is, right?
Yes.
They are multiplied by some constant, right? Always. And
Uh,
A1, A3, A5 are in arithmetic sequence.
mhm.
So geometric sequences have a common ratio and arithmetic sequences have a common difference, right?
Yes.
Common difference. And both the conditions are satisfied at once. And they are saying if A3 is equal to 1575, find the possible values of A4 times A2. Uh, right. Find the possible values of mod A4, A2.
Yeah.
They have given you the middle number and they're asking you for others.
Right.
Are you making any progress?
So we know that A1 times A5 is gonna be 3,150.
A1
So
times
then,
A5. Why?
yeah, because A3 is the average of those two.
A1 plus A5. No, not times, right?
Oh yeah, it's A1 plus A5.
Right.
Yeah.
So first of all, don't do it like that. What you should do is use this number as much as possible. So what
So
I
then,
will say is A1 and A2 and A4 and A5 can be written in terms of this and the common ratio rate.
yeah,
For example, if the middle number is 1575, the numbers are 1575 by R,
right.
1575 by R square, and on the other
Yes.
side it is 1575 R and 1575 R square, right?
Yes.
So this becomes my A1, A2, A4, and A5, right?
Uh-huh.
Now, for here, we know that you said the relation A1 plus A5 is 2A3, right?
Yes.
So we can just write this plus this is 2 times this, right?
Yeah.
So 1575 by R square plus 1575 R square is equal to 2 into 1575, right? We can
Yes.
cancel 1575 everywhere and you get R square plus 1 by R square is equal to 2, right?
Yes.
The only way this happens is because this will be greater than equal to 2 by A and GN. The only way it will happen if it both are 1.
Yes.
R square is equal to 1. And because all the integers are positive, we'll not take the negative value of minus 1. Because
Yes.
if one of the common ratio is minus 1, then some of the integers will be negative, right?
Right.
Right. So we are getting everyone is 1575, which is slightly weird. Uh, is it possible that we have missed out some solutions? 1 second. R power 4 plus 1 is equal to 2R square. No. We are getting 1 only. So all the integers are same actually, right? Uh, 1 second. 1 second, hold on. A1. Okay, I have made a mistake in the problem. What I have made a mistake is actually A1, A2, A3 and separately A3, A4, A5 are in geometric sequences.
Yes.
Basically, that means that it's not the same common ratio, right?
Right.
So we'll say that it will be R and R square here, but this side it is S and S square, right?
Yes.
Do you understand? Otherwise, the problem is trivial. Every number is 1575, right?
Yes.
Do you
Right.
understand what I'm saying?
Yes.
Now we can say that this plus this is equal to this, right? The same condition, right?
Yeah.
But now the equation becomes 1 by R square plus S square is equal to 2, right?
Yeah.
Correct?
Yes.
So now let's simplify this a little bit. So, okay, we have to think now. 1 by R square plus S square is equal to 2. And our numbers were like this 1575 by R square, 1575 by R, and 1575 and 1575 S and 1575 S square, right?
Yeah.
So, because they had given that all of these were positive integers, we know, what do we know? We know that R and R square will be dividing this perfectly, right?
Yeah.
R square divides 1575, right? And also R
Yes.
divides 1575. So let's do the factorization of 1575. If you do prime factorization of that, it becomes 3 square, 5 square, and 7,
Yeah.
right? So R
Yeah.
can be 3 into 5 then,
Right.
because then R square will divide this, right?
Yes.
It is possible for R to be 3 into 5. Other values are also possible. 15 is possible for sure. Lower values will be possible, right? Like R could be 1, 3, 5, or 15, right?
Yeah.
These are the possible factors whose squares will also divide it, right?
Yes.
Do you understand what I'm saying?
Yes.
Okay. Now from here, we can now think of what will be the possible values of S square, right?
Yes.
So S square is equal to 2 minus 1 by R square, correct?
Yeah.
And you have to keep it in such a way that these two also become integers, right?
Yeah. Right.
So in each of the cases, let's take R as 1, 3, 5, and 15. If R is 1, S square is 1, right?
Yeah.
And S is 1, you can say. That fits the conditions, right?
Yes.
If R is 3, S square is 2 minus 1 by 9. So that is 17 by 9. S square is 17 by 9. So S is root. Okay, that doesn't fit the condition at least to make S an integer, right?
Mm-hmm.
Because it will have a root 17, right?
Yeah.
Okay, so if R is 5, what happens? 2 minus 1 by 25. So this becomes 49 by 25, right?
Right.
So S is going to be equal to 7 by 5, right? Correct?
Yeah.
Which is fine
Right.
for S, and I think it is also fine for S square because 5 square is there in 1575, right?
Yes.
S is 7 by 5 is also possible, right? And R
Right.
is 1 by, basically R is 5, S is 7 by 5 is possible. R is 1, S is 1 is possible, right?
Yes.
And then you can check when R is 15 also, right?
Yes.
It may not be possible for 15. So let's just check once. S square is equal to 2 minus 1 by 225, right? The
Yes.
problem is that this is not a perfect square, 449, right?
Right.
Do you understand what I'm saying?
Yes, I understand.
For 15, it will not work out because this will not be an integer, right?
Right.
So these are the two values that will work, okay? And then obviously you'll get all the numbers, possibilities and all, right?
Right.
So A4, A2 and all now you can find out, correct?
Yes.
I hope you have understood what we are doing.
Yes, I understood.
Okay. Uh, then the next problem is this. A positive integer n has four divisors that sum of the divisors is 1 2 1 1 2. Okay. Such that the sum of its divisors is 2 1 1 2. Given that the number of positive integers less than and relatively prime less than and relatively prime to n, and this number is given the symbol phi of n,
Yeah.
is equal to 1932. find the sum of the proper divisors of n. Find the sum of the proper divisors of n. So notice that what is the difference between this that they are asking and what was already given, right?
Yes.
So they had said that n has 4 divisors such that the sum of the divisors is this, but they didn't say proper divisors, right?
Right.
Proper divisors means divisor smaller than n. N itself is a divisor of n, right?
Yeah.
So any number you can say n is a divisor of itself, right?
Yeah.
So proper divisors, when they say, they mean divisors which are smaller than n, right?
Oh, okay.
So
So
they
n
have,
is doesn't.
so here the 2112 is equal to divisor 1 plus divisor 2 plus divisor 3 plus n, right?
Yeah.
And divisor 1 will be 1 actually, right?
Right. Yeah.
So like this, 2112 is this. What you need is just this much,
Right.
right?
Yeah.
And they have given you the number of positive integers less than and relatively prime to n,
Right.
right? So try it out, or try it out as homework maybe. That we can discuss it in the next class.
Okay.
See, factorize it and all, try to factorize things, and
Yeah.
we'll discuss the relevant theory if you are not getting it. So just try it out once, okay?
Okay. I will.
And next class will be mostly AMC problems. So do the last 10 or 15 problems.
Yeah.
Whatever paper you're doing, just keep doing AMC problems. Every day you must solve some of them.
Yeah. Okay.
Okay, that's all for now. I'll
All right.
talk to you
Thank
next time.
you.
Bye.
Yep. Bye.